Well, student, in the last lecture we had completed the theory. It is about the electric dipole. Electric dipole means what? Two equal and opposite charges separated by finite distance or small distance, they constitute the electric dipole. And the equation of the dipole moment, it is given by, it is a vector P is equal to Q into 2A. Q into 2A. And also we have studied the theory about the electric field on the axis of the dipole and the electric field on the equator of the dipole. Now today is the next topic related to the electric dipole. Now to check the behavior of the electric dipole in a uniform electric field. Behavior of electric dipole in a uniform electric field. So that is your topic number 1.12. Behavior of an electric dipole in a uniform electric field. Before start this theory, first of all, we explain how to draw the diagram of the electric dipole in a uniform electric field. Student, the word is uniform electric field. A uniform electric field means what? The field lines are parallel to each other and equidistant. It is called the uniform electric field. Field lines are parallel to each other and at equidistance. It is drawn at equidistance. It is called the uniform electric field. So student, observe these electric field lines. This is the electric field lines. The field lines are parallel to each other and they are equidistant. It is called our uniform electric field. In this uniform electric field, you place a permanent dipole. You place a what? Permanent dipole. See, this is our permanent dipole. In this permanent dipole, this is minus Q charge and this is plus Q charge. Distance between these two charges, it is 2A. Direction of the dipole moment, it is from the negative charge to positive charge, denoted by vector P. Denoted by vector P. Now this dipole, it is to be placed in a uniform electric field. This dipole makes an angle theta with the vector E. This dipole moment P makes an angle theta with the vector E. Means what? Angle between the vector P and vector E, it is theta. Or also you can say that this dipole makes an angle theta with the electric field E. It is makes an angle theta with the electric field E. Okay? Student, now the total there are two forces are acting on this dipole. Force acting on the plus Q charge, QE. Force acting on the minus Q charge, it is minus QE. The total how many forces are acting? Two. Force acting on the plus Q charge, QE. Force acting on the minus Q charge, that is what? Minus QE. Okay? The total two forces are acting. Now the explanation, it is about the diagram, it is completed. Now there is some description, it is from the diagram. That description, it is to be given like this. A permanent electric dipole is placed in a uniform external field E. Permanent electric dipole, it is placed in an external electric field E, which is in a plane of paper as shown in figure. Which is in a plane of paper as shown in figure. Suppose dipole makes an angle theta with vector E. Suppose dipole makes an angle theta with vector E. Magnitude of dipole moment, that is P is equal to Q into 2L. Already studied in the last lecture. Magnitude of the dipole moment, that is P is equal to Q into 2L. Okay? Force exerted on plus Q charge by field F1 is equal to QE. Force exerted on the minus Q charge by field F2 is equal to minus QE. Now total how many forces are acting? Two. Now make their addition. So that total force F1 plus F2 is equal to, where F1 is equal to plus QE, F2 is equal to minus QE, plus QE minus QE cancel, so that answer is 0. It shows that when the dipole is placed in a uniform electric field, the resultant force is 0. Or translational force is 0. Or the translational force is 0. Okay? Hence, the net translation force on the dipole, it is 0. Now student, in this dipole, total two forces are acting, plus QE and minus QE. These two forces are acting at a different point. These two forces are acting at a different point. This value of the force, they are equal in magnitude but opposite in direction. Two equal and opposite forces, acting at a different point, they form the couple. They form the what? Couple. Once again student, two equal and opposite forces acting at a different point, they form the word couple. Couple means it is produced over torque. Couple means what? It is produced over torque. So it is a very simple example. Suppose we are holding our steering of the car. In the steering of the car, we are exerting two forces, but they are equal in magnitude but opposite in direction. acting at a different point, they form the word couple. They produce the torque. Another example, while we are pedaling of a bicycle, on this bicycle we exert the two forces simultaneously at a different point. They form also called couple and they produce the word torque. They produce the word torque. So, the student, we can say that two equal and opposite force act at a different points of the dipole. They form a couple which exert the word torque. Which exert the word torque. Now, what is the equation of torque? So that torque tau is equal to, it is a magnitude of either of forces. Torque is equal to magnitude of either of forces multiply perpendicular distance between two forces. Multiply perpendicular distance between two forces. So the torque tau is equal to magnitude of either of forces multiply perpendicular distance between the two forces. Okay? चलो magnitude of either of forces. तो magnitude of this force is QE. Magnitude of this force is also what QE. So the magnitude of either of forces replaced by QE. It is replaced by QE. Now student, we require perpendicular distance between the two forces. That is to be calculated from the diagram. Well student, this dipole, it has a distance 2a. This 2a makes an angle theta. And student, this line, it is called the perpendicular distance between the two forces. This line, it is called the perpendicular distance between the two forces. This 2a makes an angle theta. For this theta, this is our opposite side. For this theta, this is our side, opposite side. And that opposite side is equal to, it is equal to 2a sin theta. That opposite side is equal to what? 2a sin theta. So this 2a sin theta represents the perpendicular distance between the two forces. 2a sin theta represents the what? Perpendicular distance between the two forces. Therefore, this term replaced by 2a sin theta. Now student, write down q into 2a. Write down q into 2a and into it is e sin theta. Q into 2a is equal to, that is dipole moment P. Q into 2a is equal to dipole moment P. So then write down P sin theta. Write down their vector form. Therefore, torque tau is equal to, it is a vector P cross vector E. Torque tau is equal to vector P cross vector E. It is represented that when the dipole is placed in a uniform external field E, resultant force is 0, but torque is not 0. That dipole is performing a which motion? Rotational motion. That dipole is performing a which motion? Rotational motion. Once again student, when the dipole is placed in a uniform external field, the resultant force is 0. Translational force is 0, but the torque is not 0. That dipole is performing a which motion? Rotational motion. The dipole is performing a which motion? Rotational motion. Student, now this dipole is performing a rotational motion like this in a clockwise. So by rotating our finger in a clockwise, normal to the plane of paper, so that finger is moving in which direction? Inverse direction. By rotating this dipole in a clockwise, that finger is moving in which direction? Inverse direction. So that the direction of the torque is perpendicular to the plane of paper moving inverse direction. So that the direction of the torque is perpendicular to the plane of paper moving in an inverse direction. Okay, so what is our equation of torque? That is tau is equal to vector P cross vector E, or the expansion P sin theta. So now this dipole, it is aligned in the direction of the field. It is aligned in the direction of the field. When dipole is aligned in the direction of the vector E, then vector P parallel to vector E. Angle made by them is 0. Theta is equal to 0. Theta is equal to 0. Sin 0 is equal to 0. Therefore, torque is 0. Sin 0 is equal to 0, therefore torque is 0. Another example, when dipole is held perpendicular to the vector E, then vector P perpendicular vector E, theta is equal to 90. Now torque tau is equal to P sin 90. Sin 90 is equal to 1, therefore torque tau is equal to P. The value of the torque is maximum. The value of the torque is what? Maximum. So student, when the dipole is placed in an external electric field E or in a uniform electric field E, the resultant force is 0, but torque is not 0. What is equation of torque? So that is tau is equal to P sin theta, or that vector form, vector tau is equal to vector P cross vector E. When angle is 0, torque is 0, but when the dipole is held perpendicular to the field, then torque becomes maximum, that is PE. Okay?